welcome everybody to Workshop Block B. You are in the Columbia Hakuhodo Immersive Workshop. My name is Marian Bernstein and I run communications for NYC Media Lab. And I'm joined today by my co-moderator, Autumn Miller, who is the communications assistant for NYC Media Lab. So just to give you a quick rundown of what to expect for the next 45 minutes, I will introduce the team. They will take it away and give their fantastic presentation. That will last about 30 minutes or so. If you have any burning questions while they're presenting or any comments that are marinating in your mind, go ahead and type all of that into the chat box that you see on the screen, because the last 15 minutes or so of the workshop will be reserved for the audience Q&A. You can pose your questions to the Colombian Hakuhodo team members, and we can just have a great eye-opening conversation. So with that, I will go ahead and introduce our fabulous team. Like I said, we are in the Columbia times Hakuhodo Immersive Workshop. From the Columbia side, we're joined by Steve Feiner, who is a professor of computer science at Columbia University, where he directs the Computer Graphics and User Interfaces Lab, also known as CGUI Lab. His research interests include human-computer interaction, augmented reality and virtual reality, 3D and 2D user interfaces, automated design of graphics and multimedia, mobile and wearable computing, health applications, computer games, and information visualization. Professor Feiner is joined by Janeni Sekaran, who is a research assistant at the CGUI lab, and Janeni holds a master's degree in computer science from Columbia. Additional team members from the Columbia team include graduate student Jen-Shuo and recent PhD graduate Carmine Elvezio. And for 3 years, the NYC Media Lab has partnered with the Hakuhodo R&D team. Hakuhodo is the second largest advertising agency in Japan. Hakuhodo's network of over 80 offices in 17 countries and regions, with more than 2,400 employees, including locally hired staff, working outside Japan. Their team of researchers, developers, and executives include Yosuke Kinoshita, who is the group manager / chief technologist at MTC, Shingo Meguro, who is the technologist at MTC, Rotaro Sano, who is the R&D engineer at MTC, and of course, Takahiro Hirashi, who is the fellow at MTC. So with that, I will go ahead and pass the virtual mic over to the Columbia team. Take it away, Janeni.
Thank you so much, Marian, for introducing us. I guess I'll start presenting Fastball today. So Fastball is an intercontinental AR ball game. And as you've already seen, these are all the members who worked in the project for the past year and a half. And let's go ahead. So what we are seeing here is a little demo of Fastball, which is a volleyball game, as you can see. On the left side is how the player actually plays it. On the right side, what we are seeing is basically the screen sharing of how the game goes on. As you can see in this video, on the other side, you see a little paddle that says P7, which is the player name, with a cyan diamond at the top, which is basically indicating that they are handling the physics, which I will explain in detail in the future slides. And you should see this ball having this crazy effect as it passes along to the other side. This is a game played between Tokyo and US, which is very interesting, and I will elaborate on all the network topology and how it's played in the future slides. Awesome. So what is this game about? So it's a network, multiplayer, multi-team, and multi-site game. Basically, that can be more than one player in the game, and these players can be present at 2 different physical spaces who will be connected using in the single game. And right now we are connecting 2 different teams together, and each team can have multiple players in them. This is built using Unity, Android, built on Android phones, and using Google AR Core. All right, why did we choose volleyball? Initially, our initial plan was to start with a basketball game. I'm sorry, am I echoing? Um, is there an echo?
That was happening, and hopefully the staff will take care of that.
Okay, I guess we have this live. We are gonna do a live demo in the future, so we have a phone set up. I guess that's why my echo is passing along. Sorry about that. Okay, so why did we choose volleyball? So initially we thought about going with a basketball game that players will be co-located in a single site, and uh, the teams, they would have to play along closely, and this is how it started. So the first app that we ever built was a basketball game, where, as you can see in the picture, there is this basketball, the core thing that says the timer and the points, you and them, and players, both the fonts and the image represent two different players playing in a single team in a single game, and they'll be shooting balls into this virtual hoop thing that would go in, and if a player gets it, they get the point and it gets incremented. This was also a network game, networked using Unity Unit. um, the reason why we chose volleyball is because, okay, maybe first let's just see the little video of it. As you can see in the left player, when he successfully drops the ball into the hoop, you would see the U point getting incremented, and if the right player gets the ball correctly, them would get incremented, and the timer goes down, and this is basically how it's played. The Yeah. So So I will explain in detail on how this whole setup is made when I actually talk about the volleyball game. So right now, okay, the reason why we chose volleyball, back to that, COVID-19 came along during last summer, so we thought the best way to experiment this game would be to instead do a volleyball game, so that people who are at remote places at two different sites can be connected, and the teams can be separated and have fun in that regard. So that's why we thought volleyball is the best idea. All right, so I told you guys what's going to happen in the game. So the first thing that I wanted to talk about is, how do you register whatever the virtual code that we see in a volleyball? We have this net setup. So how do you register it for the space that you are in? So the first thing is, uh, we need to make sure that the virtual code is the same, aligned for both the team members. So there's going to be, like I said, two different teams, and they need to be aligned. So that they share the same coordinate systems. And when you actually serve a ball or receive a ball, you would see the ball at all times, only when it is in the same coordinate system. That's the first thing we need to make sure. In order to do that, we are basically using Google Cloud Anchors, which will basically let you tap on the screen and register the position. And when the other members of the same team scan the same environment, they would also be looking at the same net. What does Google Cloud Anchor do? It would basically scan the environment and look for these features, good features in the environment. And as it looks along, it would collect this information, and when the next player comes in and scans it, it would look for the same features. If the features are present, boom, you would get the Google Cloud Anchor result, and you don't have to host again, which is really nice. So that's about registering the virtual code. The thing is, when we were doing this, we were having problems with the stability of the net. So during one of the previous versions, we would just host this cloud anchor, and the team members would resolve it. But during the middle of the game, the net would just move along or disappear, because the features weren't strong enough for the game to continue. So what we've decided is to use this little um, um, a map equality indicator that you see at the bottom of the screen, at the picture, where you basically see this little bars that changing color from red to yellow to green, basically indicating, okay, on this side of the space, a good number of features have been detected, and it basically requires the player to go around the room and capture the net from different angles so that all the angles are covered, and when the player is actually moving around in the game, they won't actually lose the net just because they lost the particular feature that they were supposed to track. So this made the game really stable, and the net stood in the place for a really long time to enjoy a good game. Okay, next important thing that we have to tackle in this game is creating the net. So, like we said, this net is going to be in completely two different spaces, right? So you can't expect both the places to look the same. It's not going to be a room with an empty room that is going to have the same sized room, and it's just not possible. And it's just not practical. Maybe if it's just going to be experimented in a lab, we could just move into a room where there's basically nothing. But this is not going to be practical when in real life. The places are going to be completely different. The places are going to have different items, different obstacles in it. So we need to make sure that our game works in any kind of environment. So what do we do about it? So the first thing is, the room can be of different size and it can have different layout. So we need a system that can basically fit this net common to both the locations. So the first thing is that the player will be able to position and orient the net anywhere the player would want in the room. There is an option to move the net and rotate it as the player likes it. So the next thing is, player would also be able to change the width and height of the room. So that let's say we are having a really small, narrower room, and we are not able to actually enjoy the game in the actual size of the volleyball court. So we allow users to actually reduce the size of the net or increase it as they would like. So basically, when a player one enters, they would be able to do uh, both scale both the width and the height of the net. As the player A hosts the net and sets its position orientation, and as soon as they finish setting up, the width and the height get shared to the team B player. So players in the other space, when they host the net, they would essentially be seeing the net that was that is basically as of the same width and height the first player created, so that team player in the team B would know, okay, probably player in the team A, their room doesn't allow for something bigger than the net that we are seeing. So the only option that they get is that they can decrease the width and height of the net, but they can place it and orient it anywhere they would like. That is basically not going to affect the game, right? So it's their space. The only thing that should be common between both the teams is the width and the height of the net. So that is shared between them. So once both the players agree to the width and height of the net that is being that has been set up by both of them, they agree to it and they start playing by clicking the set button, and they are ready to play. Okay, next thing I want to talk about is serving and returning the ball. So when you serve the ball, so we wanted to make it like a very realistic serving as much as possible. So basically, you use your phone screen in order to just swipe up. So when you swipe up, both the extent of your swipe and how fast you are swiping both account for the force or power of the ball that is being served. So these are all very controllable parameters. We are still experimenting with how we can better improve it so that it would look more close to the real physics of a real volleyball game. So right now, both the serve extent and the how fast the ball is being served, they are both being controlled, and that's how you see the force of the ball. And the next thing is returning the ball. So when the ball comes to you, so you need a mechanism in order to hit the ball and play with it. So we had a lot of discussion on this regard, and we finally decided that we would basically have attached this virtual paddle that we would have seen in the first demo video that I just showed. On the other side of the net, you would see this transparent paddle. In the middle, there would be like a phone that's in behind it, so that player can basically hit it with this paddle. And we made this paddle size to be a little larger than the actual phone because, as you guys know, we are just amateurs. We are just trying to experiment with the game. We are not actual volleyball players. We just wanted to have fun with the game, so that we actually made the paddle a little bigger than it's supposed to be, so that we wouldn't miss it as much, and we could actually have fun with it. So that's how the paddle works. So about the paddle, force of the paddle, you would see a slider on the screen that can control this force of the paddle, and the paddle force not only takes that into account, but also the position of the player, the z extent from the unity space, wherever based on the position of the player, the force of the paddle, it also changes. So and another thing is that you can basically angle this paddle in a way, and the ball would basically go in the direction. And yeah, so based on the angle of the paddle, based on the back force that you're setting on the screen, and also based on the player's position, on how close or how far from the net they are, these all these things affect the paddle force that you would hit the ball. All right. Objects in the environment. So like I said, there are going to be objects in the environment, and we need a good way to interact with them so that and collide with them, so that we take into account all the objects and we create this new kind of game. In a real volleyball court, we wouldn't see all these things in the middle, but of course this is AR, and this is basically a game that we are building for to have as much fun as possible. So it would be really cool if we could take into account all these objects that are in the environment. So I'm just going to play a little clip where a player is going to serve the ball, and it is basically going to interact with the environment. So the player is serving the ball, and it goes to the other side. As you can see, it just hits the table and just goes along. It's having fun. So that's one of the cool physics that it does. This is basically done using AR Core's depth API, which basically creates this, gets the depth map and creates a mesh in the environment, so that as the player plays along, and it would basically interact with the environment as the player sees the points the camera to a particular location, and if the ball is falling into that particular location, the ball would interact with it. So yeah, that's about the objects in the environment. Next is practice mode. So one of the things that we noticed in our previous version is that it was both difficult for testing and also difficult for new players who wanted to use the app and enjoy it, to make them comfortable with the game, on how the virtual paddle works, on how the serving works, and how to manipulate the force that they are in and the position, to give them the basic understanding of all these things. We thought, why should we always have like a multiplayer version in order for a person to just test it, right? So we thought, okay, let's just build this automatic ball shooter that is basically this yellow hoop that you're seeing on the other side that would basically shoot a volleyball on its own. And you can basically return the balls by hitting it with a paddle. So it makes it very easy for testing, and anyone who is very new to this game can experiment with this. And there are a bunch of parameters and controls that you can change in practice mode. Basically, this hoop would move from left to right, and we are still thinking about extending this to crazy ways this hoop could move so that the player can have more fun and more meaning, maybe have fun with it in a way, like increase the difficulty of it and stuff like that. But right now you can control the speed that this hoop would move. So if the player would it really doesn't wanted to move, and you would always like to be shooting at one spot, you can just stand there and make the time limit to be 0, so that the hoop would always be at one place and it would just continuously throw out the balls. And also you can also manipulate the number of balls that it's going to shoot at any particular time. So that's basically 2 things that we can do in practice mode. Next, power-ups. So another cool thing we thought is that this is all AR virtual. So this is not actual volleyball game. What else more? We wanted to build something that's just more game-like. So we thought to build these power-ups is called slow ball, which is basically we were trying to manipulate the physics of the ball, where we would reduce the gravity so much so that the ball would basically float just slowly. And this gives the advantage to the player, so that the player can run in, and as the ball is moving really slowly, they can just tap it and the ball would go boom, it would just go really fast. So we just thought something that we were trying to build up something that would make it more cool to play, and we were having fun with the physics of these ball and basically the lowering and changing the gravity and stuff like that. The next is a pinata ball, which is basically a ball that would come at you, and as you hit it, as you can see in the image, it would just throw these confetti all over, and with a lot of with a soundtrack that would just cheer you up. And this is very, the pinata ball is one of my favorites, because when you hit it, it bursts out and this confetti comes along, and it's very satisfying to see that. So that's about pinata ball. And the relighting ball is basically, we were trying to, Core has this really cool feature where it can manipulate the lighting of the environment, since you know the depth of the environment. So basically the ball would become the light source, and it would change the colors of it, color of the ball as it hits along. And so it lights up, the ball becomes a light source, and it would illuminate the whole room in this crazy colors. And that's about the relighting ball. Oh, okay. So finally we are here with the architecture. So about the architecture, the first thing that we wanted to mention is that each side of each team or side is going to have one physics server, and this is only so no matter how many players are there in the team, there's only one physics server is going to handle all the physics of the game. We are actually thinking about what we can do better in future, but right now it's this way because let's say you are in a physical space and a ball comes along and you wanted to interact with the items in your space. The physics server should be seeing this ball, and only then the ball would interact or collide with the objects in the environment. And also the physics server is also responsible for if any other team player is going to serve, or if any other team player is going to hit the paddle, the physics server will know all the information about the player's position and orientation and the activities of the player. Did they hit it? Did the ball collide with them? Are they serving? And all those information, and it would decide on how the game's gonna go. another interesting thing about this game that we've seen is that players only experience this latency, that you see this effect, like the a zigzag effect as it passes along the net, right? It would only happen when the ball leaves your side, it happens, and when the ball returns, it just comes back seamlessly. The reason is that when you're shooting the ball, you're seeing it in as it goes along. You're seeing it in real time. So when it goes along at the net, it needs to switch the physics server, and so it basically the ownership of the ball would switch to someone like in this game, someone in Japan would take it over. So there is some kind of latency over there that we would see when the ball is leaving. But when it comes along, when they are returning, you're basically seeing in the past. So someone has already served or someone has already hit it when they did it. So when it comes along, it just comes back seamlessly. You won't see any latency when it comes back. It just comes back smoothly. You would have seen it in the initial video as well. That is one of the cool things that's happening in the game. Right. Okay, so I think what I should do in order to explain this architecture, I would need to zoom into the picture and explain it better. So I think I would stop sharing this and I would share a different screen. Give me 1 second. All right, so I guess you guys should be able to see this. Okay, a little bit of terminology on what's happening in this image. There are two teams, Team A and Team B. So Team A as players, player A1, A2, and A3, right? Team B as players, player B1, B2, and B3. And basically, these are the main players in the game. So, and I would explain along what's going on in the architecture. So the first thing is when, let's say, we are going to assume that player A1 starts the game, and when he opens the application and he hosts the game, basically he would call this master photon pun master server in order to create a game. Basically, we are using Photon is the networking package that we are using, and in previous versions we were using Unity Unit, but now we've decided to switch to Photon Pun. Pun is basically a service that Photon uses that basically gives like a dedicated server, I think a dedicated server for players to enjoy along. So when the player A1 hosts, basically.
Janani, I'm going to interrupt you for a second.
Uh-huh.
If you simply look at the tab in your browser, which you're viewing this in, without doing anything to it, you're seeing a tiny little screen share. Because this is a tab in the browser, you can actually zoom in the way you would zoom in on any tab. And if you do that, you'll be able to see much more easily and much more readably what she's showing you. So she doesn't even have to zoom in. You could actually do the zooming in yourself to whatever amount you would want. You'll obviously cut off a little bit of the views of us in a column on the side, but the more important thing right now is, if you're interested in the architecture, is to look at the architecture diagram by zooming in on it.
Yes. But anyways, so we have this Photon Pun master server. It's the dedicated server that is going to be the master, and basically all of the phones that joins in the room, they are going to be the clients of the room. So player A1 becomes a client, and to the Pun master server, and let's say the player B1 joins the same game, and it would also become a client to the Photon Pun master server. So this is the first level that you're seeing, and let's say there are going to be more players in the same team. So team A, there are going to be players A1 and A2 and A3. They are going to join the team, and let's say they are going to join the same team as player A1. They basically become clients to player A1. So let's say the player A1 is basically is the team server, and they would become clients to the player A1, both A2 and A3. Similar thing happens to the side B as well. Player B2 and B3, they become clients to player B1, who we are assuming in here is the team server for side B. Okay, so that's there. And the next thing that I want to explain is the paddle. So basically, paddle is basically the position of your phone, right? So every player has their own. The thing that you're seeing, the A2 client authoritative paddle, is basically the player A2's position and orientation that they have authority over. They have authority over the paddle that is this. And this likewise, there is an A3 client authoritative paddle that belongs to player A3, likewise on team B as well. So what's going to happen is, since the physics, there is going to be only one physics server on each team, like I mentioned before, this client, so the physics server basically would create the server instances for each paddle, so that the physics server always knows where each of the player is, and that it can calculate, let's say, if the ball is being served, if the ball is being hit by any of the players in the team, the physics server would take care of it. So we need to know that, so that there are like A2 paddle server instance, as you can see here, and there is a paddle server instance for A3 as well, and on the other side the same thing happens. So this is about that, and this is how the paddle works. And the next main thing that I want to say is that anything that happens on the other side of the team goes through the master server. So let's say there is a ball in team A, the only way that team B would see it is through the copy of a master server ball A. So likewise, same happens for team B as well. So now I would explain how the ball gets spawned and how it would get transferred to the other side. So let's start with team server A, server authoritative team A ball. This basically means that the team server A has this someone in team A has spawned a ball, and that comes under the server authoritative. And since it's in team A ball, we're just mentioning that it's a team A ball. And once this ball gets created, a copy of it gets copied to for every other player in the team. So A2 gets a local copy of team ball A, and A3 gets a local copy of team ball A, so that they can all see this server authoritative team ball A, where it is, who's spawning it, and all those information. Now we want this ball to be copied to the other team as well, like I mentioned before, and this gets copied to team server A client authoritative master ball A. What is this? This is basic, since there's both team player A1, player B1, they are both clients to the master ball A, master server. Since this is the case, they are going to only have team server A client authority. So the copy of it gets transformed to the client authoritative master ball A, which would then reflect onto master ball B. The thing is, we can directly connect team server A, server authority team A ball to master ball A by adding some more handles to the game. But right now, this is how it's being done. But even if we directly connect it, it would essentially be the same. So once the transform, by transform I mean both the position, the orientation, they all get reflected onto master ball A, because every player should always see the ball spinning around, where the position of it, and all those information. And once it gets transferred to master ball A, as you can see, it goes like along, and it gets copied to the other team's server authoritative team B ball. So they would basically see a ball on the other side of the net that's coming along. And so since since the copy gets transformed to the team server of B, the other players of the team, they also get the local copy of the team ball as well. So that's how every player in the team sees a version of the ball, no matter wherever it is in the game. So this is basically what happens on one way. The same thing happens for team B. If team B were to serve or hit the paddle, the copy gets transformed to the master ball B, and then it will get copied to the server authority team ball A, and the same thing follows. So the main thing is there is only one ball visible at any point in time. When the ball crosses the net, it would deactivate the master server would basically deactivate whichever side it's coming from, the ball whichever side it's coming from, and it would activate the other side of the ball. So yeah, this is about the architecture of the game. I guess I would go back to the presentation. 1 second. Tab. Okay. All right. Okay. So now, since we are done with that, I wanted to talk about a little bit of the future work that we are thinking about. Right now, like I said, there's only one physics server, and only the physics server would know where the ball when the ball comes along. Only the physics server takes care of the collision and all those things. But we would like to change this in the future, and we would also like to send whatever the physics server is on the other team players are seeing, the depth information, the depth texture, onto the other team as well, like basically making it more like a mixed reality game, either by scanning at the start. The only thing about scanning at the start of the game and sending the depth mesh over to the other team is that the other team won't be able to see the environment would be then considered to be static, right? Anything that's added in the middle of the game, the other team won't see that. So that's the drawback about sending it if you were to send it initially before the game starts. But that's still in the discussion, like what we can do about sending this depth information to the opposite team so they can actually see what's going on, what's behind each player as well, and not just the player position and orientation, so that they have a much fun game. So that's the first thing. And the next thing is, for amateurs like that, even when we are testing the game out, it's always very difficult to play along, to return it continuously. Like a pro volleyball player, it's often very difficult. So what we thought is, maybe since we are already considering the position of the player who is hitting, why not consider the position of the player who is on the other side of the net as well? And let's say there is a physics server player, let's say there is a player B on other side of the other side of the net, and as a player A, as I'm hitting the ball, I would my application would both consider my position and the position of the player B and exert the right amount of force so that it would go on and go to the right location instead of the player actually having to try it. So we discussed that it would actually be interesting to have these modes, like how much of an assistance you would like for the game. If you are a pro player, you basically won't need any assistance and you can just play along. But if you're not, if you set the player assistant to really high, or you can just call it like an easy mode, and you'd basically be standing there and holding the phone, and the game would basically play on its own, and you don't have to worry about moving around and actually trying to hit the ball. So we thought this predicting the ball path in order to influence the forces, or is an interesting thing that we would really like to consider in the future. So yep, so that's it for the presentation. Thank you very much. I guess we would do a live demo right now.
No, I think actually we don't have a lot of time left, and people probably want to ask some questions. So I think at this point it makes more sense to take questions.
Got it. Okay. Let me stop sharing.
All right. Thank you so much, Janeni. That was fascinating and complex for sure. So we have about 5 minutes left for the audience Q&A. If anyone has any questions or comments that you would like the presenters to address, go ahead and type those into the chat box now. We already have a compliment, Janeni. Betsy Barker says that you are amazing.
Thank you, Betsy.
We agree. I have a question actually while the wheels are turning over here. Um, so we've all been home essentially for the last year and a half. How would you say that COVID has impacted AR innovation as a whole? Or has it?
That's an interesting question, I think. You could even ask how has COVID impacted innovation as a whole, not even being specific to AR. Um, I think in a diversity of ways, some good, some bad. Being isolated, not having to do some of the normal things that you do on the way into work and out of work, being able to work from home and not having to commute, for example, means there's more time, at least in theory, to go and do the thinking and working that you would do that you wouldn't get to do if you were traveling in a car, for example. Um, so, in some ways, you can argue that it's positive. In other ways, of course, it's very depressing being in the situation that we are around the world right now. And I think that has, for some people, made them be less productive. I think it's an interesting mix. Um, Certainly, in the case of technologies like Zoom, for example, the technology that we're using right now as well, um, this has become something that people, just a couple of years ago, some people used a bit, but many people didn't use. And now there's a lot more people using it. And the idea that even as part of this, there's some AR things going on. Every one of these applications has the ability to put a little hat on, uh, add some facial hair, make some modifications, which really are augmented reality, modifying the view that the camera has of you. Somewhat cheesy, but they're better now than they were back in the early part of 2020. Um, so I think that people are getting more of an appreciation of what these kinds of technologies can do, and I think that is going to make a difference. And of course, at the same time, although it's not really something you could chalk up to COVID, we're seeing devices like, for example, the Oculus Quest 2, which, as of just a matter of weeks ago, now has made it possible for people to be able to use it in video see-through mode as part of a regular application. So you can have a grayscale background of the world around you behind the virtual content that you're seeing. And that is, in fact, augmented reality, even though the only things that the application can actually pay attention to in the way in which Facebook has implemented this is the head and the hands and controllers of the person or people in the application. You can't actually analyze or do anything with the visual content that's intentionally kept away from you as a programmer. But the idea that $299 device can actually do video see-through AR is pretty impressive. So I think that the better phones that people are relying on, maybe more so than they were relying on them when they could see people more readily in person. All those phones are running, if they're iOS or iPad OS, they're very possibly running ARKit. And since a lot of those applications are free, they're probably at least one application that you're running will be an ARKit one. If you have an Android phone, or for that matter, an iPhone as well, you could be running AR Core, which is what we were using for this application, although the depth API part will not run on anything other than Android. So the idea that we can have these things that are AR apps like this running on a commodity phone, um, and there's large numbers of them that can be downloaded for free, I think is becoming important. People are not going, certainly in the past year or so, although it's changing a bit right now, are not going to stores in person. They're buying things remotely. This is great, I think, for Amazon, but it's also great for the Wayfarers of the world, for House, for a variety of places that are providing you with applications that let you see in your environment a chair or a table or a piece of furniture. And those are all applications that are making money for folks and that are doing it courtesy of the increasingly better phones that we have. And as well, the fact that it's more likely that you're going to be shopping remotely when you're concerned about the danger of showing up in person in a store.
Well said. And I saw a few virtual thumbs up get sent during that response. So thank you so much. Timing wise, it looks like we've got time for maybe one more question. And this is for you, Taka. Arthur Slotnick asks, could you please provide insight on how this technology is being used in advertising?
It's interesting. Firstly, the Hakuhodo, we identify ourselves as a communication agency. Of course, we are advertising agency, but we are trying to create a new type of communication among the consumer and between the brand and media and the consumer. Our focus is always on the consumer and active consumer. And advertising is always beyond the communication for us. So we are trying to, this is just a kind of a research, and this is it's our first step, but we are trying to create a new cyber, virtual, and then also the real world blending type of a communication. So what the Janine demonstrate is our focus is how we can blend the virtual ball bouncing on the real object, that type of area. So, and if we can achieve that type of interaction, maybe advertising beyond on top of that. That's our perspective for this project.
Sounds good. Thank you so much, Taka. All right. It looks like I see more thumbs up. That's great. It looks like we're out of time here. I just want to thank both the Columbia and the Hakuhodo teams. Thank you so much for presenting and joining us today and sharing your expertise. See some hearts coming up. That's fantastic too. If anyone wants to get in touch with you, if anyone wants to get in touch with you, how can they do so?
Well, certainly for me, you can send me email. My last name, Feiner, Feiner, at cs.columbia.edu.
Awesome. Thank you so much. So once again, thank you so much to everyone. Thank you so much to the participants. On deck, we have our workshop block C.